So, hello students, and welcome to this health analysis with Python Pandas blood test data that we are going to cover in this section. So, we have some students with us who have completed Python Pandas. Some students are yet to start the chapter, but here we are discussing a project. So, in this project, we have a sample blood test report here. So what we have done here is, in this blood test report we have randomized the names first of all. So these are just random names, but in this data you can see we have age, we have gender, hemoglobin, WBC, that is white blood cell count, platelet count, glucose, and cholesterol. So if you are doing a real-time analysis, you can take many more parameters here. We have just taken some parameters, but you can take a lot more parameters here, like there is SGPT, SGOT, ALT, right? Parameters particularly related to liver, parameters particularly related to kidney, and so on. So you can take those parameters, but just for explanation, what we are doing here is we are taking these parameters so that you can understand the concept how this whole thing is going to work. And in this case you can see we also have a variable which says is unwell. Okay, so this particularly means, is the person unwell? 0 means the person is not unwell, 1 means the person is unwell. Okay, and we are trying to analyze those parameters which is causing some kind of disease, or which is causing, or which is becoming a reason why the person is unwell. So first of all, you understand what is a target variable and what are feature variables or input variables, right? Is this clear, Soumya?
Yes, sir.
So whenever we start our analysis, first we have to make sure which particular variables we are taking as target variable and what particular variables are output variables. So in such data sets we have inputs and output. Okay, inputs and output. Inputs are these data over here and output is this particular thing. So the in regular case the program will be like, if we input or if we provide hemoglobin of a person, WBC, platelet, their glucose count, their cholesterol value, and their gender, if we provide all of these informations, even their age, then our program will predict whether the person is unwell or not. Okay, so these type of problems are called problems of, this is a binary classification, right? Because the output has only 0 or 1 values. So first of all you have to understand this. In this case we have 50 examples, but all of you can collectively work on research. You can collect this data. You can collect from several sources, like suppose you had a blood test or someone else had a blood test in your family or friends. If you will collect such kind of data and create a CSV file or store it in SQL file, wherever you are comfortable with storing it, then you can perform this kind of analysis. You can either use Tableau, you can use Pandas, you can use Power BI, whatever you want to use. So Apurv and Sapna, I want you to work on this data set. I want you to use Tableau to analyze all of this. Okay, prepare some kind of dashboards, and Soumya will work on Python Pandas. Okay, so now the first part is to read the data set, and after reading the data set, working on it. Okay, so now when it is clear that it is a problem like a binary classification where output has only two values, either 0 or 1. Okay, so in this kind of problem, or in these kind of problems, we will apply classification. Okay, this type of problems fall under classification. So in machine learning, this is just a simple revision for everyone. In machine learning, mainly there are two types of machine learning. There is another called reinforcement, but mainly there is supervised and unsupervised machine learning. Okay, supervised machine learning is what? When you have inputs, sample inputs, and output data already there. So supervised machine learning is a case where you already have your inputs and output data, and then you have to perform some analysis, and then you have to come up with some kind of model that can predict the data. So you will teach the model on the basis of problem itself. And in case of unsupervised machine learning, you only have the inputs. Okay, so that's why this particular problem is supervised machine learning, because we have our features, these are called features, and we also have a target value. Okay, so or we can say we have our inputs and we have a output value. So in such cases, supervised machine learning algorithms will be used. And in supervised machine learning, there is classification and there is regression. Okay, so classification and regression are two type of cases, and in every case there are different algorithms. So we have done these type of discussions in previous chapters also, where we have used regression to find per capita income, predict per capita income of a country. We have used regression to predict sales or profit of a country, right? That we have done in past. But this time we are going to do it with pandas. So I am inside my Google Colab. I have connected Google Colab, and when you have a CSV file, okay, so for example here we have a CSV file. So whenever you have a CSV file and you want to analyze it, the first thing that you have to do in Google Colab is click on this folder. I think Sapna, this was your question also, right? So you can click on this particular icon over here, and on this when you will click on this icon, you will see an option to upload. Okay, Soumya, this is Google Colab. It works just like Jupyter Notebook. Okay, and you can log in with your Google account in Google Colab and open a new notebook. Okay, all you have to do is just search Google Colab. So in this case, you don't have to install anything in your computer. Just open Google Colab and click on new notebook. Okay, and your new notebook will open here and will be opened, and from here you can just connect. So after connecting to the runtime, you can start coding. Okay, so that's what we have done here. So first of all, we'll upload the file. So what we are going to do is we will upload this file. So this is an Excel file first of all. what we can do is I have also saved its CSV version. Okay, so this is the CSV file. Okay, so I'm going to upload the CSV file. Obviously you can upload Excel file also, but I am just uploading the CSV file over here. And when it gives you this warning, just click OK. So now you can see our file is uploaded and it is of 2.38 KB. Okay. Now you have to note down when you have to connect. I'm writing here, right? When you have to connect JSON, SQL, CSV, Excel, okay, XML, HTML, etc. When you have to connect with these files and you have to analyze the data, then we use Python Pandas library. Okay. So this is a library or a package in Python Pandas that can connect Excel and CSV files, and it can present the data in the tabular format. Okay. So all you need, and when you want to use any additional library or a package in Python, all you need to do is you have to write import pandas. Is it clear? We are importing a new library. We are calling, so this is the library called pandas, and this library is used for data processing and cleaning of data, wrangling of data. We will do a lot more videos on this. We already have a lot more videos on our channel, from starting to many projects that we have done on pandas. So all you need to do is you just write import pandas and then call it PD. Okay, so we are just making the name short and calling it as PD. We have done these things in SQL also, right? In SQL we can rename the columns. Okay, so import pandas as PD. So Ayush has just joined. So Ayush, so now we have connected the data, and after connecting the data, what we are doing here is we will just run this. So these are called cells. Okay, जैसे there is when we were doing idle, so when you were using idle, in idle we used to run the code line by line like this, right? X is equal to 15, y is equal to 5, x plus y. So this is line by line we are doing the code. But here in Colab or Jupyter Notebook, you have to run every cell. Okay, so you just run it by pressing this particular command over here. So this is one way of running. You can also use shift plus enter. Okay, so just use shift plus enter to run. Is it clear? Shift plus enter to run that particular cell. So now what has happened is, now this particular library is available. Okay, and now we will read the data. So data is equal to pd dot read underscore CSV, and here you have to write the path of that CSV file. So first question is, which file are we reading? Which file are we reading currently? A CSV file, right? So when you are reading a CSV file, you will just call it pd dot read underscore CSV. Okay. If you are reading an Excel file, so what you will write? Read underscore Excel. If you are reading a JSON file, you will write read underscore JSON. Is it clear? So if you are reading an HTML file, write read underscore HTML. So this is how easy it is, right? So what we are doing here is, first we have imported the library called pandas as pd, and then we are just reading the csv file. Okay, and when you are using a csv file, in that case, click on csv file that you have just uploaded to your Google Colab and click on copy path. Okay, Soumya?
Yes, sir.
And Sapna, you are asking the same question, right? So all you have to do is just copy path and here just paste the path. Okay? And now run this cell. So when you will run the cell, now what has happened so far? We have this blood test data. We have patient name, age, gender, and so on. We have many columns. We have this blood test data in CSV format. We uploaded it to Google Colab, and then we imported pandas library as PD. This is just the alias. There's someone has a name Chotu in Ghar, right? So someone has a alias Chotu. So we all have, sometimes our pet name is different. So we can say the same about this. So we are just calling pandas as PD, and then with pandas we are reading CSV file and this, and we are saving all of this into data. And when you will write data, what will happen? All that data which was inside that CSV file in tabular format, it is now available here. Okay, so here just the column name is are they sick. Okay, we have called this is unwell, whatever you want to call it. So these are all our columns. Is it clear? So
Yes, sir.
we have the data here and it is in the tabular form. Now what is this particular output called? So we have, so first of all I will put a text file over here. So we have studied list, we have studied set, we have studied dictionary, we have studied integer, string, and so on, right? So these are all built-in data types of Python, like complex, boolean, whatever we have studied so far. These are all built-in data types of Python, right? All of you understand this, right? But when we import pandas library or package or module, what happens is the output that this particular data or this particular method gives us is called a data frame. Okay, what is this called? A data frame. So it is called a data frame. Will you remember this? And this data frame is a 2D data type. Okay, it is a 2D data type, is a class which is 2D. You can see here, right? You can see it has columns, it has rows and index. Every row here has an index. 0, 1, 2, 3, 4. Every row has an index. Do you remember any other data type which has index in it?
Arrays.
List is there, right? Arrays in other programming languages, but list is there which has index, right? In the same format. 0, 1, 2 and so on. So in list, for every object in a list, we have an index, and then the same way it is for Python pandas also. Okay, so this is what you can do. Now After reading the data, we'll do some, first of all, we'll do some exploratory analysis. This is called EDA, exploratory data analysis in this part. So if you will write data.head, now you have to take out your notebooks and start writing, or maybe this is a notebook, I will provide you one. So top n rows. In SQL we can print top n rows, right? Select top 10 something from data, right? So here all you have to do is write 3, for example. So what this will give you is top 3 rows from top, obviously, right? So this will give you top 3 rows. If you want last 3 rows, so if we have head, then other is tail. Okay, so this will give you last 3 rows. So the first 2 methods of pandas that you have to remember is head and tail. Is it clear? Is it clear to everyone?
Yes.
Head and tail. Head gives you top something, and here you can write your value, right? By default it gives 5 rows. Let's say you don't write something, so by default it gives you 5 rows, but if you will write a particular number here, it will give you those many rows. So the first, as you can see, when we studied list, we studied about methods of a list like append, extend, insert, copy, clear, reverse. Do you remember? We studied all those methods, right? Similarly, when we studied set, in set also we studied all the methods. What were our methods? Our methods were is this joint, difference, intersection, and so on. So in the similar way, pandas also has its methods. Okay, so this is how you write panda. Now this next thing is how to select one column in data frame. So we have many columns here. Suppose we just want to select one column. Okay, suppose we just want to select one particular column. So do you remember from dictionary we write data is square bracket, and here we write the key, right? If you remember from our last class what we did, we have a key and a value, right? So here you can choose any key. For example, you can choose age key. Okay, and this will select one column for you. So with one square bracket you can select one column, and this is a single, or yeah, or you can say 1D data. Okay, this is a one-dimensional data. When you select out of a 2D data frame, out of a 2D table like data frame, if you will select one column, it is obviously a 1D data. Okay, and next is how to select multiple columns. Obviously you can play this video again in order to practice all of this, because you have to remember all these tricks and methods of pandas. Okay, because all of you are studying data analysis, and pandas is the library which will help us in all that data analysis work. So first we learned how to connect or how to select one column from our data frame. Now we will select data, and write another bracket inside this bracket. Okay, so we have written two brackets. Or what is the easiest way? First, prepare a list of columns you want to select. Whatever columns you want to select, you can prepare a list. So for example, let's say we want to select age and gender and hemoglobin. So we will prepare a list to select. We will prepare a list. And how is a list prepared? With the help of square brackets. Okay, so prepare a list. In the list, write down all these columns. First I want to select age, then I want to select gender, and then I want to select hemoglobin. So this is what I want to select. Then write data, square bracket, and this time just pass the list here. So this is the easiest way to select multiple columns. Can you see now? So that's why to select, we have prepared a list here, and then just write data, square bracket, and pass that list. So this will give you more than one column. Okay, and you have to remember, whenever your output is looking like this, okay, whenever in your output you can see headers, you can see something like this, so it is always a data frame. And how to check that? You already know a method called type. So when you will write this and run the code, so you will see it is pandas core data frame. So the type of data that is there when you select many columns is called a data frame. And the type of data when you select one column, so when you select many columns, it is called data frame, and when you select only one column, it is called series. Series is 1D. So today all you have to remember that series is one dimensional and data frame is two dimensional. Okay, series is just like a list. Okay, just as we have list, we have series, and data frame is more like a dictionary, right, where we have keys, and in those keys we have many values. Okay, so this is data frame. So obviously we are going with very basic details to understand everything, to learn from scratch. We are also learning pandas as well as some core concept here. Now suppose you have to find out from this data age, suppose we have to plot some graphs. Okay, how to plot basic graphs? Because when we are analyzing the data, graphical analysis is very important, right? So how to plot graphs? This is very easy. So suppose we have data age. Okay, so what we can do, just write data age dot plot kind is equal to hist. I will explain this. First let's see. So you can see a graph here, right? What we call it is a histogram. Okay, so this is the easiest way of plotting a graph. Plot is our method. So the method that we are using here is called plot. Kind is what kind of plot you want to draw, and here you can see, right? Can you see line, bar, bar H, hist, box, KDE, density, area, pi, scatter, and hex bin. So this is the this is why Google Colab is very helpful, because it will give you other options also. For example, suppose we want to plot a line graph. So all you need to do is just write line there. Okay. If you want to plot a bar graph, all you need to do is just write bar here. Oh, sorry, I have written bad bar. So it will plot bar graph for you. But when we have selected only one variable, remember this, when we have selected only one numerical variable, then histogram is the best kind of plot to see how the data is distributed in our data set. Okay, we are testing how the age is distributed. So this is distribution of age. What do you mean by distribution of age? Obviously we have done this graph in Tableau also. From Tableau you also remember this, but when we plot a distribution plot, it starts from the minimum value, goes up to the maximum value. So it is starting from 25, that is the minimum age in our data set, going up to 60, that is the maximum age in our data set. And can you all tell within which particular range we have most number of samples?
30 to 35.
Right? You can see here, right? You can see a peak here that within 30 to 35 we have a peak. So this particular data gives us an indication of how the age or any particular variable is distributed over the complete range. So what this means is within 45 to 50 there are 6 people, within 30 to 35 there are 8 people, within 55 to 60 there are 3 people. Does everyone understand this or not? What is right? What is the histogram plot representing? So this is our first analysis, kind of the EDA that we are doing, which is giving us an information that we have people from different age groups. That is what we can analyze from here. Okay. We can write another parameter here called bins. Let's try this. Let's say bins is equal to 10. So now you will see we are not seeing a change. Let's say bins is equal to 15, because by default it is 10. So now you will see a data like this, right? Bins is nothing but number of bars, number of intervals that we are taking. So earlier the age group 25 to 60 was divided into 10 subgroups, but this time it is divided into 15 groups, right? We can increase, let's say we want to do 25 bins, then you will see now your data is distributed into 25 bins. So now you can clearly see within 25 to 30 what we have, within 30 to 35 what we have, and so on. Okay. So this is our first graph that we are understanding here. Then we have another variable called gender. Okay, so we are writing data and we have a data called gender. So in this case, when we select gender, so this is not a numerical data. Histogram can be plotted in a numerical data. Okay, but when the data is not numerical, here the data is not numerical, is it? We have male, female, right? So every value is a string here. So in this case, you have to remember a method called value underscore counts. Those who have studied SQL, they remember a clause, they remember group by clause, right? we used to do aggregate values with group by. So it was like something like select count of gender, select count of ID, something like this, comma gender from data, group by gender, something like this, right? In this case, when you will write this, it will give you this simple answer, that in our case the data is evenly distributed. It's not like we have the samples that we have taken, we have 25 samples of male and 25 samples of female. And by the way, this data can also be plot. So when we are plotting something, we just write a dot, a plot, and then you just write kind is equal to. In our case, we are writing kind is equal to pi. So you can see it is giving us male and female equally distributed. Okay. So we are keeping this discussion up to this point. I will provide this file to you. I first of all, I want everyone to present me this much, right? You have the file, you have the code, you have the video, you have the explanation, everything. All you have to do is just go through all of this, go to collab. I will provide you files and everything after this class. Just go through all of this, and even file and the code links will be provided in the description of the video also, that I will upload on YouTube. What you can just go through it, do this much, and then when you will come back in the next class, then we will discuss it further. Is it okay, Soumya, for you?
Okay, sir. सर मुझे कहाँ तक करना है?
You see, now you have this data set, you know exploratory
Yes.
data analysis. Okay.
Yes.
First, perform whatever analysis you can perform. Okay. Like how hemoglobin is distributed, WBC, right? You can also use Seaborn library to plot different type of graphs and understand how is data, what type of data is given here, right? So you can use pair plot of Seaborn to understand different things. The most important thing is we have to find out how these parameters are affecting this output variable, right? What parameters are contributing in those patients who are sick or unwell, and what parameters means what is the range of hemoglobin for healthy people, right? What is the range of hemoglobin for unhealthy people? Same, what is the range of cholesterol? So we will try to find out the combination of these features which is causing the people to get sick. Okay, obviously this is a random data that we have collected, but in actual, when the data will be actual data, okay, so we can come up with better conclusions, right? Like if your hemoglobin is in the range of 7 or 8, okay, then people have some problems, right? Usually hemoglobin should be between 11 to 14 range somewhere, right? 12 to 14. In case of females it is different, in case of male it is different, but this is what range of hemoglobin is. Same with cholesterol, same with glucose, right? There are ranges. So from where are those ranges coming from, right? Whenever you have a blood test, you have those parameters which are not within the range. Those parameters are either marked as red or bold, right? So that you have to focus on those parameters. So that's what we are doing here. We are trying to explore those ranges. So from here, the variable which is called are they sick, this is helping us in finding out those ranges of variable, right? What is the healthy range of hemoglobin in our case. Okay, what is the healthy range of WBC in our case? So do you get what we are trying to find here, Samya? Right? So just go with it, try to analyze as much as you can, and then we will connect once again to discuss this.